I captured it. No. Okay. The amount of queries depends is totally dependent on number of prefixes we have, and it can burden the router, and it can add the CPU memory resource consumption on the network. With summarization, we can fine tune the network. But we should be well aware of the network where the prefixes exist, where you can do summarization. Summarization basically says you have 5 prefixes: 10.1, 10.2, 10.3, 10.4, 10.5. You can try to summarize that all the networks with one single statement or two separate statements. So instead of 5, we only have two prefixes. That obviously reduces the EIGRP table, also reduces the query messages. So when a query message is sent, say when there is no backup path, if we have a backup path for a particular prefix, we immediately paste that in the routing table. Say if we do not have a feasible successor, then we have to send a query message to all our neighbors, and all the neighbors has to check their routing table whether a particular prefix is available for them to reach. If they have the reachability, they should report back. If they do not have the reachability, they should reply back with an infinite metric. So number of queries can be controlled by two things. One is called summarization, and one is called stub router advertisement. Okay, let's do summarization now. Which was the slide I was in? Yeah. Query is generated when a route becomes an active. When the route becomes an active, if the link is down, or that neighbor is down, or we change some metrics, that time the particular route becomes active. Query is sent for exact match of lost route. Say we wanted to reach 1.2.3.0/24, we will send query to all neighbors asking that we wanted to reach 1.2.3.0. Reply is immediately sent if there is no match. Even if the router has a match, it has to send a match. If it doesn't has a match, it has to send I do not have for 1.2.3.0/24. So yeah, you should ensure that you should be aware that 1.00/8, though 1.2.3.0/24 belongs to 1.00, but that router doesn't reply saying I have route for 1.00/8. It just looks for the exact match 1.2.3.0/24. If I don't have a route for 1.2.3.0/24, it replies saying it replies with an infinite metric. So if we had all these related routes in single prefix, then there would, if one of the prefix would have gone, there wouldn't have been any query, because the whole network is still available. So there wouldn't have been any query. It would be still sent to the same router. Summaries can be enforced anywhere. You should be aware of the topology where we can put the summary. It can be placed anywhere. Unlike OSPF, where we have restriction, or where we have a design thing saying we can do summarization in ABRs with all. But in EIGRP, we do not have such thing. We can place it anywhere. Where we see multiple networks are advertised from specific router, we can place summarization there. But the older iOS had an auto summary by default enabled. Once you enable router EIGRP, there was an auto summary enabled, which means it will do summarization between the major network boundaries. Say there are two networks, there are three networks: router A, router B, router C. Router A has 10 and 10.1 and 10.2 network, and when it's advertising, router B is on 172 interface. When router A wants to advertise 10.network to router B, it will advertise only 10.network, not 10.1 and 10.2. That is called auto summary, but that is disabled by default. Now it's so if we wanted to advertise something specific inside after doing auto summarization, that is called deep map. Okay, let me go through this practically. 1 minute. Okay, I will advertise multiple networks from loopback R1 router. So we have 4 loopbacks here. Loopback 0, loopback 1, it's 1.1.0, 1.1.1, 1.1.2 and 1.1.3. So current routing table in R2 looks like this. We have one path to reach 1.1.10. We are not advertising the other networks still. So we'll advertise other networks here. Okay, still in R1, sorry. So we advertised all loop paths. How to ensure we advertised? Anybody have the command to tell? Okay, you have to give show IP EIGRP interfaces. So this command clarifies on what all interfaces we are running EIGRP. Loopback 1, loopback 2, loopback 3. So now we can check the R2's routing table. We have 1.0, 1.1, 1.2, 1.3 and all. We'll enable the for query and update packets. Hello might be too many packets. So there are no query packets as of now. Let's shut down one of the interface. So 1.1.0 is not available. You see how much query traffic generated for one prefix. It was 1/0 was shut down, so it started asking 0/0 about the network, but no reply. So we'll make one more interface down. You can see again we generated some query packets. So we'll bring back both. So the routes we back in routing table. So now we'll do a summary on the. We do typically summary on the interface. This is the command we use. So I have to do summary on the 0/1 interface. I'll do summary on both the interface, because if I do summary on one interface, these networks will be advertised on another interface. So router will still have these entries in its routing table. Suppose there are two paths. So we'll do summary on both the interface 0/0 and 0/1. We have to do summary on R1 wherever all the prefixes belongs to. Here where all the prefixes are originated. So we do here. Okay, I do summary on both the interfaces. So 1.1.0.0 is 255.252.0 will summary all the address 110 to 113. So all the old routes gets flushed out because this router will tell that router that it will stop advertising those routes and it will advertise only a single route. So no changes in this routing table. It's R1 here where we have behind the change. So you can see only one route now, unlike earlier. We have only one route now, unlike earlier, whatever we had. We had all four routes earlier. Now everything is summarized to a single route. Say and you have to see here we have one EIGRP route introduced here 1110/22 is a summary and it's a null zero VTEL. There is a discard route that is added once whatever summary you are doing on an interface, a discard route is added, null zero route is added. This is to avoid any loop actually. Say router 1 we are advertising 110/22. Say for example we didn't had a route for say we didn't had a route for 1121, but this router with respect to R2 1121 also belongs to R1, so it will still send a packet to R1, but R1 might have a default route back to R2, so R1 will send back to R2 because 1121 if it's not in its routing table it will send it back to R2. So there will be a continuous loop between R1 and R2. So if we have a null zero route, if the router R1 doesn't have a route for 1111, it will drop the packet within that router. It will not send it back to R2 because there is a route pointing to null zero interface, which means the packet is discarded. So that will save some CPU memory, which otherwise it would have caused a loop and the packets will be rolling between the routers till the TTL expires. Okay, now we'll make one interface down. So 111, we still had 111 in our routing table. Our topology table, okay. I think this was only an update query packet. Okay, there are no query packet. I think this is only an update whatever it is sending. because this router is advertising back saying that 111 is not available, but this router did not query any other neighbor or did not query anybody else, so the queries are stopped here. Even 111 is not in its routing table. 110 is not in its routing table. It has 110/22 still available. You can see compared to the earlier query packets how many we had and how much we have now. So that is the advantage we get on summarization.